Hi guys. I'm going to try to get my act together a little bit better here. I've got this assignment that you may have already seen here, and the home page that's called a module, and um, I've put up links to two YouTube videos. This guy is hilarious, and he's really good at explaining things. And so this is Introduction to Waves. You really need to see this, I think, before you try this assignment. And then he goes a little further and more mathematical here, and you might want to give that a try as well. And you can always ask me questions. I see discussions. Perhaps I'll get that enabled because then everybody can see all the questions. Okay, so you go in here. And first of all, so this is the actual assignment. And then you can't post folders in Canvas. So the next best thing are these pages. And there's some PDFs, and then there's this doc file. And so that's what I have it here. So you can read it over here. And they ask you to describe these wave patterns that you see. And remember, it's similar to, well, it is. What you're seeing are, when you have the two, let's get it up here again because it's a nice gravity waves annotated. This is the one we were looking at. Yeah, it gets huge all of a sudden when I put annotations into it, I think. But remember this, the operation of the interferometer. Now, just a little subtlety here. And look at one of these data files. What you're seeing here in the data file is, and let's look at the screen. When it rotates, we look at the screen here on the right. So the data plot are not these sine waves. The data plot is the intensity of this spot. So when the intensity is zero, is dark at 0, and then when it goes above the axis is when the purple line is on one side, in advance of the yellow line, or if the purple line is after the yellow line. So when the two sine waves go back and forth, you see it goes up and down in intensity, but we see it just get bright, dark bright, but it's bright from one orientation of the two sine waves, and then bright from the other orientation of the two sine waves. So that's what you're seeing here. So in principle, if you had two massive objects like two black holes or two neutron stars revolving around each other, then you would see these waves coming through. And as they inspiral, they, let's see if it's here, no. As they inspiral, they go faster and faster. So the waves, so what you're looking at in the first plot, it looks pretty steady. But you can see they gradually grow in amplitude because, and also the period changes. And the amplitude is because they're getting closer together, and so they're generating bigger ripples. And then, of course, as they get closer to each other, they spin around each other faster and faster. So just so you know how to relate what you're seeing on these data plots. Now, it's good to be, I always like to understand what's going on. Now, yeah, so I basically helped you understand how to fill in these blanks. And there you go. So and this is a Word file, so you can change the spacing here for your answers. If you want to, you can print it out and handwrite it and just use Adobe Scan. There is some fancy looking equations here. They're really not that hard at the end of the day, but we can go over them. I want to see if you guys have a crack at it, because it's always better, I think, to just get started on a problem first, and then it informs your questions so you can ask better questions. But this is really interesting stuff because it gives you a sense of how we do the calculations. So then when you read about what's been discovered at LIGO, you'll have a better ability to understand what's behind the announcement that's been made. Okay, very good. We'll stop this.